Money makes the world go round. In fact, it's hard to do without it.
But however much or however little money you've got in your pockets, there are ways you can make it grow.
Can I pay £20 into my account, please? This is definitely a first.
And when money is deposited in a savings account at a bank, it starts to earn interest. I'm at one of the UK's biggest banks, and inside here are the computers responsible for doing all the sums. Sadly, this facility isn't available to you in your maths exams. The computer you'll be using to calculate interest is in here.
In maths, there are two types of interest you need to know about: simple interest and compound interest. You also need to be able to calculate the amount of interest earned after several years, not just after the one.
As the name suggests, simple interest is easiest to calculate. A typical question might be, calculate the interest earned if £50,000 is invested for 3 years at 10% per annum simple interest. You're given three things here: the amount of money you start with, which is £50,000, also known as the principal amount, the length of time it's invested for, which is 3 years, and the interest rate, which is 10%, expressed as a percentage per annum, which simply means per year. To calculate simple interest, first work out the interest after 1 year. After 1 year, the interest is 10% of 50,000, and 10% is 10 hundredths, which is the same as 1/10. Multiply that by 50,000, which is £5,000. Next, you need to multiply that by the number of years you're investing the money for, which is 3 years. So £5,000 multiplied by 3, which is £15,000. You might get asked a question like this in maths, but in reality, banks don't work this way. They use compound interest.
Compound interest gives you more, but it's also more complicated to work out. You need to work it out year by year. So to calculate the interest earned if £50,000 is invested for 3 years at 10% per annum compound interest, well, in true maths for real style, it helps to use a table. In the first year, the principal is £50,000. So the interest earned is 10 hundredths, or a tenth, of 50,000, which is £5,000. But here's the difference. You then add the interest earned to the original amount, the original principal, which is £55,000. So 55,000 then becomes the new principal at the beginning of year 2. So in the second year, the interest earned is 10 hundredths, or a tenth, of 55,000, which is 5,500. You then add 5,500 to 55,000, and you get 60,500. So 60,500 is the new principal at the beginning of year 3. We then work out the interest, as before. So we get the final amount is 66,550.
Remember, Jamie and I started with the same principal and the same interest rate. So, how does the amount of simple interest earned after 3 years compare to the amount of compound interest earned?
The total compound interest is 66,550 minus the original principal of 50,000, which is 16,550.
Compared to £15,000 with simple interest.
I think you'll find that I win.
Hello. Now, you know, I've always fancied to go with Carol's board, and she's gone, so now's my chance. And here's a Maths for Real top tip for calculating a percentage increase. Now, let's say you've got a principal sum of £1,500, and you want to know how much it's going to be worth after a 6% increase. Now, the long way of working it out is to say that 6% is the same as 600ths, and 600ths of £1,500 is £90. And so, after a 6% increase, the new principal is £1,590. But here's a useful shortcut to calculate the new principal in one single step. To add a 6% increase to £1,500, simply multiply by 1.06. Now look, if I can do it, it must be simple.
But where does the 1.06 come from? Think of the principal sum you start with as 100%. An increase of 6% means that you'll end up with 106%. 106% is the same as 106 hundredths, and as a decimal, that's 1.06, which is why multiplying £1,500 by 1.06 gives you the value after an increase of 6% has been added.
That's my favourite part of the show now, where Katie and I have to do some maths for real. We're both going to answer the same question, but only one of us will do it correctly.
The other will make a deliberate mistake, which you have to spot. You decide. Do you tick it or trash it?
A principal of £500 is invested in a savings account for 2 years at 6.7% per annum compound interest. Calculate the total amount in the account after 2 years, giving your answer to the nearest penny. Pens at the ready? Go.
A principal of £500 is invested in a savings account for 2 years at 6.7% per annum compound interest. Calculate the total amount in the account after 2 years, giving your answer to the nearest penny.
To find the amount of interest after 1 year, I multiplied 500 by 6.7 hundredths, which is 33.5, or £33.50. So after 2 years, the total interest will be £33.50 multiplied by 2, which is 67. So the total amount in the account after 2 years is 500 plus 67, which is £567.
To find the new principal after an increase of 6.7%, I decided that I needed to multiply £500 by 1.067. So after 1 year, the new principal was £533.50. A further multiplication by 1.067 gave me the total after 2 years, which is £569.24 to the nearest penny.
So whose working should you tick and who should you trash? Did you spot the deliberate mistake?
Was Jamie right with an answer of £567?
Or was Katie right with an answer of £569.24? OK, I was wrong. My mistake was forgetting that with compound interest, the interest earned is added to the principal at the end of each year. What I've calculated here is the total using simple interest.
The method I used is ideal for answering a question about compound interest over several years. But be careful. If this question had been about simple interest over several years, this method wouldn't have helped.
Katie, do you know money and banks are like, well, Posh and Becks?
Or Richard and Judy?
Or Tom and Jerry then?
Because you can hardly have one without the other.
Yeah, but the tricky thing is to work out how banks can afford to pay you interest.
Well, they can do that because banks act in the middle between the customers who are savers and the customers who are borrowers.
When you save money, you earn interest, so the banks pay you.
When you borrow money, you pay interest into the bank.
Show me the money.
Say Katie borrows £1,000 and the interest rate is 8% per annum. That means after a year, as well as paying back the loan, Katie also has to pay the bank an additional £80.
Say Jamie saves £1,000 at the bank with an interest rate of 5% per annum. After a year, Jamie gets back his original £1,000 plus the £50 interest he's earned.
So overall, the bank makes £30.
Banks make money by having different rates for borrowing and saving, and so make a profit on the difference. Borrowing money from the bank is the only way some of the world's poorest countries can survive. But like any loan, if you get behind with the repayments, the debt can quickly build up. For many developing countries, ever-increasing debts have led to ever-increasing poverty. How did these poor countries get into so much debt?
In the late 1970s, a lot of money was made available at low interest rates to third world countries. And because they needed then, as now, to spend money on health and education, they took up these loans. But shortly afterwards, the interest rates rose and most of the world went into recession, which hit third world countries hard. And as a result, they were unable to pay back the loans, which spiraled out of control.
What sort of size were the initial loans and how much bigger are they now?
Initially, hundreds of billions of dollars were lent to third world countries. Right now, with additional loans and interest rate growths, the total debt is about $2,500 billion. Now, many people are poorer now than they were then, so there's no hope they're going to pay this back. If there's ever going to be any improvements and prosperity in third world countries, their debt has to be cancelled, and that's what we're trying to achieve.
Compound interest is partly responsible for making loans so difficult to pay off. For example, if a country borrowed £85 million at an interest rate of 5% per annum, how long would it take for that debt to rise above £100 million if no repayments were made? For each year, an increase of 5% means multiplying the principal sum by 1.05. After 1 year, 85 million multiplied by 1.05 gives a total of 89,250,000. To find the figure after 2 years, multiply this number by 1.05, which gives a new total of 93,712,500. Multiply this number by 1.05 for a third time gives a total after 3 years at over 98 million, and multiply this number by 1.05 for a fourth time shows us that after 4 years the debt has broken the £100 million barrier if no repayments are made. In maths, all these calculations can be done in one much shorter step. To calculate the total debt after 4 years, multiply the principal sum by 1.05 4 times, which is the same as 85 million multiplied by 1.05 to the power 4. And if you work that out, you get £103,318,031, which is exactly the same as before. If you work it out after 10 years, that £85 million of debt will have grown to a colossal £138,456,043. That's more than £50 million of interest. With debts of this size, it's no wonder that some of the poorest countries in the world have little or no prospect of ever paying them off.